Hi guys, it's Mr. Hackathon here, and today we are going to a hackathon in East London, the Complex Worlds Hackathon. And a part of the challenge is to use reinforcement learning to model dynamic world environments over long horizons. It's going to be an exciting day, so let's get going.
Morning folks, howdy, I'm Jeff. Brief bio is, I think my connection here is, these days I focus on a lot of understanding agent and coding intelligence. We are building RL environments, we're building them on open reward, been kicking the tires since day zero. So a lot about the platform. Background-wise, I spent a long time at Fair and PyTorch, where I worked with Ross on a bunch of cool things, some papers with code, things like that. So really interested to see this next generation of work for RL and in the open is what we're doing.
Hi everyone, my name is Brahim. I'm doing research at Nebius, mostly about software engineering agents and RL environments at scale. Our main projects are Page leaderboard, where we assess models capabilities every month on real world and fresh software engineering problems. And the next one is Page dataset. It is the largest open software engineering RL environments dataset that was widely used by several frontier labs to train better coding agents. But I have a very non-traditional background for ML research. I'm a dentist by training. That's why I'm looking. So I've kind of hedged my career. If AI will take over, I will just go and work as a dentist. So yeah, thanks for having me. And I'm looking for new cool projects and creative ideas that we can use to build better RL environments and make open source great again.
Yeah.
Hi, my name is Giovanni, and I work at Pencil Scientific. We build agents for scientific research. So it's kind of like relatively normal agent stuff, but in a domain where being very rigorous and actually trusting the results is extremely important. So reliability is of particular interest to me.
Okay, thanks for that big sound. Okay, hackathon begins.
So the hackathon has begun and I haven't actually got a partner. There's people sitting outside. There's a couple people by themselves. I do want to speak to them and say, let's join up. But part of me also just wants to get on with it and build. We'll see. We'll see by the end of the day if I do actually join up with anybody or anybody comes to join up with me. With the aid of ChatGPT, we have an idea we're going to go with for the hackathon. We generated some ideas, and with ChatGPT, we kind of spoke through crossing them off. And I said whether I liked it or didn't like it, and we crossed it off, came down to a final two, but ended up going with this humanoid caretakers idea. And the idea is a long horizon environment where the agent cares for an elderly person, adapting to evolving health and family dynamics. And it's called Heartline RL. So the agent has to adapt to
an actual person
that they're taking care of.
Yeah.
But it might not even just be one person, right? Like you have a family member that come visit, a doctor might come visit.
and how they interact with everyone else
Exactly.
as well. Yeah.
So if you think about aging populations, you think about humanoid robots, whether you're talking about Elon Musk's humanoid robot or maybe even small versions that are more
the thing is, if you have this artificially, online essentially, then you can move into hardware and stuff like that. So if you have a proven concept of this working, then this will actually be a foundation for it to evolve.
Exactly. That's what I'm thinking. Yeah. I don't think it's easy on the platform. Let's see here.
But yeah, that's what reinforcement learning's for.
Exactly. Exactly. It's not an easy task. And you think about all the tools that it's going to need. It's going to need visual recognition. It's going to need RAG capabilities. It's going to need multimodal capabilities, like medical reasoning.
Crazy context engineering.
Exactly. It's going to need all these different things to tap into, which is incredibly hard. And that is just for the sole purpose of like taking care of an elderly person. I'm sure like a companion bot that's just like for like a healthy teenager might be a little bit different in terms of the needs.
100%.
But the elderly person, the tools they need access to, the reasoning will be almost completely different. So just trying to get that online. So far it's going so good. We've got maybe like 3.5 hours left. So
3.5 hours left.
well, how long till we got to submit?
5.
4.5 hours.
5 latest, 4:30 submission.
We'll see how it goes.
That's how it goes.
Yeah. So what have you guys been working on?
So we actually moved into the medtech space.
Okay.
So we're doing triaging.
Nice.
So we're essentially using reinforcement learning for triage nurses. Essentially it gets in all the context with structured inputs as well, and has a choice of what priority it should be listed as. And then
I guess it has to change priorities based on like new patients coming through the door.
If there's like a bus which has crashed and 20 people influx and stuff like that, that's definitely in the works for future development, but for the base standard we're just trying to do one at a time. So it seems really interesting. It has real world applications, and it's a critical system within the NHS and hospitals. So that's what we're doing.
All you can see is pretty much lines of code, and I think you can barely see that. But we have it running locally, which is extremely difficult to do in a hackathon, especially so early. I have maybe like 3.5 hours or 3 hours. So I have a lot of time left. It gives me more time to experiment and do something crazy. But we have our long horizon environment for elderly care. Is this a normal use case?
I think it's a bit unclear to me what the reward function would look like for this. Because again, you ideally, I guess for these tasks, the most tractable ones are ones that are computer verifiable. So that is to say that it doesn't require human judgment basically to assign reward to the rollout. Which is not to say that it's not possible to do it with human input. It's just a lot more expensive and difficult, obviously, because you then have to have a human look at it, and it's more subjective, and it's really expensive, and it's slow.
I guess if I make it in a way where it is sensor-based, for example, if you have issues with your iron level or your liver, or where it's blood tests and like quantifiable, then the computer can do that.
Yeah, I mean, if you can roll a reward function right, it takes in some vector of things and outputs on a scalar. And if you can like imagine what that function would be and write it in a way that a computer can execute it, then you're kind of fine. So that would work. As far as the current paradigm for training these models goes, this is not going to scale. I suppose you could do the rollouts like off policy, do them like offline, kind of.
What do you mean not going to scale?
Well, like this takes 8 weeks, right, to do one rollout. Let's say.
I just put 8 weeks, but
sure. Like, a lot of our, if you're training, like Cursor, for example, right, they every 5 hours release a new version of the model, and they do a full reinforcement learning run every 5 hours, basically. And that includes data collection, data cleaning, doing the rollouts, doing the updates, and publishing it. It takes 5 hours. And they do that every 5 hours, like round the clock. And I think their input data is they collect use data from the using Cursor, and obviously they use that to like...
I mean, but that's fine if you're doing software use cases. Like, there's certain use cases where that works, right?
This is true.
And there's many use cases where that it just won't
that,
work.
that is as maybe. Yeah, that is as maybe. And I think in this, for this particular task, it may be the case that, yeah, we just have no option but to do these, like...
Yeah.
And how would this look? I suppose probably you'd get, like, you do effectively a clinical trial.
Yeah, it'll be like a clinical trial.
Yeah, I mean, that would work. I think it's a little bit different to the usual model. I think that we build these, or that people use these environments in right now, which is like, certainly we aim for example, stuff that's like, ideally, like tasks that are hard to like complete but easy to verify. That's the dream.
Okay.
And then also tasks that we can generate like a shitload of examples like pretty cheaply.
Yeah.
And a shitload of scenarios. Yeah, I guess the other problem as well maybe with this is like you can't really do evals on this, right?
So,
Because you can only sample each rollout once. You can't resample the same task.
the same, yeah.
And be like, okay, do we think the model got better or worse? That's I guess the other thing. I guess you've got, if you did enough of these, you could do a statistical comparison of like the total reward scores, I suppose.
Yeah.
As in, like, you run it over 1,000 patients, aggregate it, and then...
But that's almost how healthcare is already done, right?
Yes.
It's it's in line with healthcare, and if they're doing a drug test, they can't do the same. They can do the same person, but they're not doing the same person. They're doing.
Yeah, this is a slightly, as I say, it may be interesting, but it's definitely a slightly different way to the way that we think about these environments. We are trying to get away from, you've probably noticed this, like a lot, most of the like big environments are like, as you know, coding and math related.
Yeah.
And that is because, I guess, there is a lot of alpha to be had in building systems that can code really well.
Yeah.
And two, those problems are easily verifiable.
Yeah.
And it's easy to generate a lot of like, there's so much code on GitHub, it's pretty easy to be like, you can make tasks from like GitHub repository pre a pull request, pull request, and then like the fixed code, like that tuple of things makes it very easy to like programmatically make like loads of tasks for this. So this is I think a bit different in that respect, but definitely I had not really considered running sort of an environment like this. Yeah. But yeah, I'd be interested to see what discussion you get out of it. I think it's quite an interesting idea. So.
Well, we know things are moving to like real world.
Yeah, so. I mean, again, a lot of people are interested in robotics. Unfortunately, it's not a focus of us at the moment, just because we obviously have finite time and money and skill, frankly. None of us are robotics pros. But yeah, I think the robotic stuff is really interesting. I think a lot of the robotic stuff still has been, and a lot of the research that I've read is focused on, instead of having to run an actual robot, can we simulate this? Yeah. And then hopefully we'll get some like transfer learning from that into like reward stuff. But yeah, that's kind of the limit of sort of moving atoms around that I've seen. Yeah. But yeah, pretty much everything at the moment focuses on bits and very specifically focuses on massive code.
Like the AI logic.
Hang on, what would be really interesting for this?
Yeah.
What would be really fun is if your environment server, basically, I guess a medical patient, right? It's kind of like a hidden Markov model, as in you observe like a few things, which are like your medical observations. Yeah. But in the background, there's like all this hidden state, like what's going on inside the body that you don't know. You don't know. Now, I think what would be really interesting for this, and what add to this, is if you had an LLM on the other side, this is going to be kind of like slightly adversarial now. If you had an LLM in the server that basically simulated the state of the patient, right? Yeah. So
that's all the hidden stuff going on inside the body that the LLM is kind of like.
Well, the agent, and then it's basically the agent's job to like kind of figure out what's going on. And you basically run an LLM with state through the environment server that represents the patient.
And so week 2, it kind of looks at it again.
Oh yeah, so week 2, maybe the thing simulating the patient is like, okay, this week you're gonna have like you're gonna pick up some kind of illness. Yeah. And then obviously it'll have to like generate realistic looking diagnostic information, which again the agent can like read. Yeah. And then I guess maybe it's the agent's job to like figure out the right diagnosis. Right?
I think we've made all the updates. What we have done is now we're taking in quantifiable information, we're taking in blood pressure, we're taking in heart rate, we're taking in a lot of quantifiable information that's informing the agent actions, which you could also validate against. But we also have a hidden state that's influencing a lot of these measurables that the agent doesn't actually know about. So an agent might make a decision and there's a hidden state that the agent doesn't know about influencing that decision. So it's a lot more realistic and a lot more interesting, and we are going to test it now. We can see oxygen saturation, we can see blood pressure. Do you want a world where the elderly are cared for, even when no human can keep up? There's smart people all across the world that are working on humanoid robotics. The challenge is we're not training them for long-term responsibility. This is why I worked on a long horizon environment for elderly care. The agent takes in a couple inputs, such as the age, the initial status, the living situation, but also measurable indicators, such as blood glucose level, blood pressure, oxygen saturation. The agent is able to use specific tools such as medical reasoning, medical question answering, and logical reasoning, and more. Here, the agent is perfect for this use case because the agent is going to suggest actions, it's going to act in the real world, but at the same time, there's a time between when it acts to when it actually gets feedback. The goal is long-term outcomes, not short-term wins. There's also hidden states that the agent's not aware of that makes it particularly interesting. So let's take a look. I have my server running, and I'm just gonna call it. You can't actually see because of the sun. I turned around, you can't see because of the sun. But this is my server running right now. And what you should be able to see, or hopefully at least the people in the front row, what you could see is you can see certain weeks, you can see information about the patient, you can see week 1 context and how the model, or how the agent is responding. You can start to see week 2 here, and it's going week by week and responding to previous weeks and how the information is changing over time. What the agent can't actually see is some hidden indicators, such as the family state or the patient's mental state, but it is impacting the patient outcomes. So this is where this loop closes. There are a couple challenges with this method, or using the long horizon for this method is credit assignment. You don't actually know which action got to the particular goal of improving the patient outcome. Small mistakes can compound, so the agent is not going to actually get the reward for several weeks in this case, and the mistakes can compound over time, which is terrible. And also balancing competing goals. So there's goals on health, well-being, which we're trying to improve, but you want to also make the family happy. You want to also make sure the patient is mentally in the right state, taking their medication, and these are all the things that the agent is balancing.
You've got like 20 seconds.
I don't think we had time for questions, but I focus on this because my mom is ill. She's been ill for a very long time, and she lives by herself. So me and my sister travel a lot, and I think about the future, and I do think with aging populations, we are going to see a lot of people use robotics to augment the assistance of humans. Thank you.
Yeah, first of all, just a thanks to everyone. I think we were really impressed by the diversity and the quality of the evidence you showed today. We gave you a challenge, kind of show SF what it doesn't know and go ambitious and be bold. And I think they're very impressed by the knowledge, but also the productivity as well. So really well done. But the runner-up, this is the first prize, so drum roll. We gave it to the Agro Manager project. Do you have anything you'd like to say?
Thank you.
Yeah, I think we were impressed by I think it hit the themes like Long Horizon, obviously. It like had this kind of low complexity net, and yeah, we also like looked at the underlying implementation as well, and then it looks to be like very, very strong. So we really like that one. Okay, then we have the winners. So the winners, I'll hype it up a little bit. So I think what we're impressed by this effort is probably two things. First of all, the productivity. We're like very impressed by that. Like we said, we did have like time limits today, and yes, we all like coding, but productivity is still like a agentic trait for us as well. And then the second thing I think we're impressed by is just the scalability aspects, right? Because I think although we said to like a proof of concept today, we did want it to just be something that can actually be built on and scaled up and be very useful. So with that in mind, we gave it to the Endgame team. Against the 519 and 518, but that would be, I think it's a little bit, so we're really well done. Is there anything you'd like to say?
So, I really need this GPU because I also is a co-author of the CETA environment. We are heading for submitting the paper to NERSC, so we are a bit short on GPU. We may not be able to finish the experiment on time. So if I had this, I would go and train the agent. Thank you.
While I was listening to your presentation, I was really touched by this kind of energy that I didn't feel for a long time. Because even when I was doing previous startup, I've seen startup founders come with great ideas, but it's one thing to have a great idea, another that touches your heart.
I think with this hackathon, there was a lot more kind of like friendly almost. Like people were very encouraging. There were a lot of like ideas. There was a lot of sharing. There wasn't like sometimes you'll see hackathons where people just like run off to a corner and just like really go all into it, which can be fun. But I think here it was a lot more almost collaborative, and yeah, I think the projects turned out, especially given the time, like even a lot higher quality level than others that I've been to. Basically, we think that games are really cool and that games are one of the most accurate sort of simulations of real world. So if you could get an AI agent to be good at playing a game, you could get them to be really good at operating in the real world. So long story short, we basically built games games into an environment to benchmark AI agents and then at the same time allow them to train as well. Yeah. I think there's sort of like a noticeable shift across almost all the labs. A very easy kind of like indication of this is benchmarks. So like benchmarks went from HLE, which is Humanities Last Exam, to sort of like these static questions where that was like the gold standard. But LLMs have just like smashed past all of that. And they've moved into more dynamic, kind of real world, actually useful benchmarks. So people like Merkle, for example, or Scale AI, who are the big data annotation companies, they've moved from, instead of again producing sort of like Humanities Last Exam type STEM standard questions, to producing what Merkle calls RL Apex environments. Yeah, I mean, I think that basically just indicates that for LLMs to be really useful and to kind of like move towards AGI, which is the aim of most of these companies, you do have to shift from something that's static to something that is dynamic, and RL environments enable that.
But yeah, how was the day? It wasn't even a day, was it?
No,
it was
like 6 hours. 6 hours, honestly.
Yeah. I think like 1 hour of just crashing on like what we do, and then actually building.
Yeah. That's usually the case though. Right?
Yeah. I was really surprised. Most people didn't actually build though.
Yeah. Sometimes you can get away with it. If it's not, I don't think they were that strict in the judging. Yeah. Usually it's like a criteria.
Yeah. Normally there's like submission requirements. This time it was very vague.
It was very informal hackathon judging.
Yeah.
Sometimes that's nice though.
Yeah. Although I think if they did specify, I would have liked it because I'm like, okay, because like I feel like we spent too much time on the front end.
Yeah.
And I'm like, oh wait, we didn't really need to care about the front end.
Yeah.
So.
Yeah.
But you never know. Like sometimes it's nice. Like even mine, I just basically had the terminal, and I'm like, this is just words. Like it's nice to have like a nice flowy. Yeah.
But you still got your point across. That's why I think the judges liked it. Yeah. Also, the amount of time allocated to each presenter was a bit. I don't know about that.
Yeah. Some hackathons, they're really strict. Yeah. They're like, okay, 2 minutes, get off.
Yeah.
Any more hackathons coming up? I think Bessel might have one next week.
Yes.
I think I applied to that one and the Cursor one.
Yeah. I haven't applied to Cursor. Yeah. It's probably too late though, right?
Yeah, it's fully.
No, I mean, now in London, there's like hackathons happening all the time. Yeah. There's one in like May 1st where it's like a Mac Mini hackathon.
Oh, nice.
Yeah, like winners get a Mac Mini. So I applied for that. Let's see if I get in. I think that one's very competitive.
Yeah.
But yeah, I mean, like London is in a place now where a lot of tech things are happening. You just need to be in the loop of it.
Yeah. All in all, I don't think that's the worst way to spend your Saturday. If you're a hackathon enthusiast like me, spending your Saturday and Sunday tinkering with new technology, meeting developers, discussing grand ideas is almost the perfect way to spend your weekend. Sure, I love to win, especially love to win hackathons, but I did learn a lot. This hackathon was relatively relaxed. I could have done with some GPUs, but it's very hard to judge ideas. There were a lot of great people with a lot of great ideas. This is probably the first vlog I've done of an actual hackathon for the YouTube channel. Usually I'm doing a lot of tutorials, and a lot of those tutorials come off the back of things I've done at hackathons or relationship with brands. But hopefully I go to a lot more events and I start to capture more, especially across the world, because there are a lot of events across the world. I'm meeting interesting people, playing around with really, really cool technology, and I can't wait to show you more.